Hi students, welcome to Madras Math Kernel. Today we are going to learn Chapter 3 Pair of Linear Equations in two variables. So in this you are going to learn concepts and example explanations related to exercise 3.2. Okay, so here now you are going to learn about the graphical method to find out the solution of a pair of linear equations. Okay, so it is similar to what you learned in the last video. So considering the example 1, I have just drawn the lines because I don't want to repeat the same story again. So I have drawn two lines here. So if you see, these two lines intersect at this point 4,2. I have taken this data from the previous example. Okay, so here 4.2 is the common point that lies on both the lines, because each and this line they will have infinite number of points, and this line also will have infinite number of points. Since these two lines intersect at this point, what you can observe, this point, particular point, lies on both the lines. So you can call this as the common solution for both the line. Therefore, what you can observe, for a given pair of intersecting lines, right, you will get only one solution. Okay, and then considering the example 2, so in the last video, if you go through the last video, you can have some idea about these examples. So after plotting the points, what you got from the series of steps, you will end with these lines. So this, up to this, it will represent one line, and this will represent the second line. So if you see here, both the lines will coincide with each other. So as I said, one line will have infinite number of points, another line will have infinite number of points. Since these two lines coincide with each other, then what you can say about these lines is, each and every point on the lies on both the lines. Why? Because they coincide with each other. If you say some point here, that point will lie on both the lines. If you say some point here, this point also lie on both the lines. So finally what you can interpret, you will be having infinitely many solutions for a given pair of lines which coincide with each other. Okay, then again considering the third example, there you got two lines like this which are parallel to each other. So since they are parallel, they do not intersect with each other, therefore there is no common point for a given set of lines like this. Therefore you don't have any solution for a set of lines which are parallel to each other. So this is what you have to learn before entering into the exercise 3.2. So for a given pair of linear equations, you will end up in three conditions. First condition is, sometimes you will get unique solution, or in some cases you will get infinitely many solutions, and for some cases you won't get any solution at all, therefore no solution, right? So when you get unique solution, you can call those pairs as consistent pair. For infinitely many solutions, you can call the pairs as dependent or consistent pair, and for no solution you can call those pair of linear equations as inconsistent, right? And then coming to, again I am writing the general form of pair of linear equations, that is a1x plus b1y plus c1 equal to 0, and a2x plus b2y plus c2 equal to 0, right? Why I am writing these things? I am going to write the conditions required in order to interpret the given lines, they have unique solution or infinitely many solution or no solution at all, right? So what are the conditions? Without doing any major calculation, you can easily say these lines have unique solution, these lines have infinitely many solution, and this pair of line they have no solution. So what are those conditions? So first one, I have written the general form as coefficient of x is a1, coefficient of y is b1, constant term is c1. Similarly here it is a2, b2 and c2. So what are the conditions here? for a unique solution, this a1 by a2 should not be equal to b1 by b2. That is, on dividing these two numbers, they should not be equal to they should not be equal to the answer you will get on dividing b1 by b2. Okay, therefore whenever this condition is satisfied, you can call those lines as intersecting lines. In the graph you will be getting the lines are intersecting and the solution is unique solution. Okay, similarly a1 by a2 is equal to b1 by b2, and that should be equal to the ratio c1 by c2. This condition should be satisfied for two lines to be coincident lines. Therefore you can interpret from this ratio, or from this answer, that those two lines they have infinitely many solution. Okay, then you find the ratios a1 by a2, b1 by b2, c1 by b2, and if you found a1 by a2 is equal to b1 by b2 and this b1 by b2 is not equal to c1 by c2, then you can say the lines are parallel and they don't have solutions at all, right? So these are the conditions. These conditions you have to remember while working out problems related to pair of linear equations, right? Then coming to the example 4, check graphically whether pair of equations that is x plus 3y equal to 6 and 2x minus 3y equal to 12 is consistent. If so, solve them graphically. Okay, so you have to check whether they are consistent. If so, you have to solve them graphically, right? So first, before going to the graphical form, actually in the example in the book they have not mentioned this, so I am explaining you. So what is the condition for consistent? You have to verify the ratios, that is a1 by a2, b1 by b2, c1 by c2. You have to find out, and you have to check whether they are not equal or they are equal like this given in this particular condition. Okay, so I am finding out what is my a1 by a2. a1 by a2 is, so this is coefficient of x is a1, here it is a2, so it is 1 by 2. And what is b1 by b2? It is 3 by minus 3, and my c1 by c2 is equal to 6 by 12. Okay, is it right? So 1 by 2 and 3 by minus 3 and 6 by 12. So if you check the answers, this a1 by a2 is not equal to b1 by b2. a1 by a2 is not equal to b1 by b2. Okay, so from this what you can infer, they have unique solution. Okay, these lines they have unique solution, and also they are consistent. So I forgot to write this, so you have to write this part even before finding out the x and y points for this particular equations. Okay, so from this you can arrive that the given pair of lines are consistent. Then as usual procedure, what you do, you put a table. Okay, you put a table like this. You find out what is y from the given equation. So y is equal to 6 minus x by 3. Then randomly you substitute x as 0, you find the y value, and substitute y as 0, you find the x value. You will get the points. You mark these points on the graph. Okay, you will get a line for the corresponding equation, and then you draw one more table. Again you find out x and y values for the given second equation. So for second equation I got the points as 0, minus 4 and 3, minus 2. After marking these things on the graph, I got two lines like this. One is x plus the 3y equal to 6. This is the line for first equation, and this is the line for second equation. Okay, so after drawing the lines, I found out these two lines intersect at this point being 6, 0. So it is the solution of these two lines. It is having unique solution, and they have concluded the pair of equations are consistent. Okay, and then coming to example 5, graphically find whether the following pair of equations has no solution, unique solution, or infinitely many solutions. So 5x minus 8y plus 1 equal to 0, and 3x minus 24 by 5 plus 3 by 5 equal to 0. So this is the question given. These are the equations given in the question. So I have marked this as equation 1 and this is equation 2. If you inspect the equations, here the coefficients are regular integers. If you see the coefficients here it is an integer and these two are observed to be fractions. So in order to make these numbers into integers, what I am doing, I am multiplying the entire equation by 5. Why? Because in both the denominators I have 5. If I multiply the entire equation by 5, this 5 will go off. Okay, so 2 into 5, which will get you equation 2 into 5. This is equation 2. So 3 into 5 is 15x, and then plus into minus is minus. When you multiply 5, when you multiply this term by 5, that 5 will go off. So you will get 24y plus this, again here also 5 will go off, you will get 3 equal to 0. Okay, again if you see here, these are the multiples of 3. Okay, 15, 24, 3. So I divided the entire equation by 3. So I got 5x minus 8y plus 1 equal to 0. This is my third equation. That is, I manipulated the second equation, and now this is the other form of your second equation. So if you observe the equations, equation 1 and equation 3 are identical to each other. Therefore, what you can say, they are, since 1 and 3 are identical or same, they are coincident and they have infinitely many solutions. This is what the conclusion or interpretation you can do it here. And coming to example 6. Okay, so what is your example 6? Champa went to a sale to purchase some pants and skirts. When her friends asked her how many of each she had bought, she answered, the number of skirts is 2 less than twice the number of pants purchased. So how many skirts she purchased? Number of skirts is 2 less than twice the number of pants. So if you take the number of skirts as x, number of pants as y, then twice the pants is 2y. 2y minus 2 should be your x. Okay. So here I have taken number of pants as x and number of skirts as y. So it is coming reversely. Y is equal to 2x minus 2. Okay. So what they said, number of skirts is equal to, skirts is 2 less than. So 2 less than means you put a minus 2 here, 2 less than twice the number of pants. So number of pants I have taken as x. So it is 2x minus 2 equal to y. So this is your first equation. Okay. And then reading the remaining question, the number of skirts is 4 less than 4 times the number of pants purchased. So skirts, number of skirts, what I have taken, it is y. Y is equal to 4 less than. So you put up a minus 4 here. Okay. 4 less than 4 times the number of pants, so 4x. So this is your equation 2. Okay. So performing a regular procedure here, that is, I am putting up a table in order to tabulate the x and y values. So I got, okay, I got x, and first equation is y is equal to 2x minus 2. Similarly here x, and my second equation is y is equal to 4x minus 4. So what I do here, I substituted x as 2 and x as 0. So I got y as 2, y as minus 2. Similarly here, for substituting x 0, I got y as minus 4. Then you substitute y 0, you will get x as 1. Okay. So if you mark these points, you will get 2 lines like this, and you could observe these lines, they intersect at these points, at this point. So what is that point? It is 1, 0. From this, what you can arrive is 1 is your x value and 0 is your y value. X, what you have assumed, you have assumed it as pants, and y you have assumed it as skirts. Therefore number of pants is 1 and number of skirts is 0.